Hello students, welcome to Naran PU College online classes. So in the last video we have discussed about the Lewis dot structures for the molecules. So that is very important for your PU examinations. You have to follow the 4 rules we have already discussed, and just I will just once recollect those all rules. The first one is you have to calculate the number of valency electrons. If negative charge is there on the molecules, how much unit of negative charge is there, and those many number of electrons you have to add. If positive charge is there, and those many electrons you have to subtract. That is the second rule. And third rule, you have to select the central atom. Usually we will take the less electronegative atom as a central atom. And the next one, you have to write the skeletal structure. Okay, skeletal structure means how you have to write? To put the central atom, and around the central atom you have to arrange the remaining elements. Clear? And after writing the skeletal structure, you have to write the pair of electrons, means 2 electrons between the central atom and terminal atoms. Clear? And after keeping the electrons between the 2 pair of electrons between the central and terminal elements, the remaining electrons we have to arrange for the terminal atoms, not the central atom. First complete the terminal atom octet, and after remaining electrons, after completion of the octet of the terminal atoms, and the remaining electron should be given to the central atom. Clear? And you know hydrogen and fluorine, they always act as a terminal atoms, because fluorine is the most electronegative element, and just now only we mentioned highly electronegative elements we will not use it as a what it is over here, central atom, because fluorine valency is 1, so that's why it can form only one bond. Hydrogen also, if having only one valence electron, it can form only one bond. Hydrogen and fluorine, they can form only one bond. Clear? But central atom should have the characteristic, it should form the more than one bonds. Clear? Because central atom will be there, around this central atom there are so many atoms will be present, so it has to make a bond. So it should, central atom should have the capability to form more than one bond. So that's why hydrogen and fluorine always we will consider as a terminal atoms. Clear? That we have already discussed. Now, and this Lewis dot structure, it follows the octet rule only. Clear? And we have discussed what is the octet rule. But in this octet rule, we have some limitations. So what are those limitations we will discuss in this class. Clear? So first of all, what is octet rule. Clear? We have already discussed octet rule. The atoms of the elements combined together, either by transfer of electrons from the one atom to another atom, clear? Or by sharing of valency electrons, clear? In order to get the octet in their valency shell. To get the octet, molecule or atoms to get the octet, they combine. How they combine? Either by transferring of electrons or by sharing of electrons, and that rule will be called as a octet rule. But this octet rule has some limitations. Mainly 3 exceptional cases are there. And what are those exceptional cases? Means I put here subheadings, and those are main, and some other limitations also there, and all we will discuss one by one here. Clear? The first one is this octet rule, limitation of octet rule. The first one is this octet rule is mainly applicable for the second period of elements. What are the elements in the second period? Beryllium, boron, carbon, nitrogen, clear? Oxygen, that is fluorine. Clear? So for this only, it is octet rule is mainly applicable. Clear? Now I mentioned here 3 exceptional cases are there for the octet rule. So what are those exceptional cases? You know that if any atom or molecule having 8 electrons in their valency shell, and those molecules are stable. Those are stable. It can be molecule or atoms, according to what it is here, octet rule. But some molecules are there which violates the octet rule, but they are still stable. Clear? So what are those? We will discuss here. So incomplete octet of the central atom. In some molecules, central atom is having less than the 8 electrons. Clear? In some, see, the number of electrons surrounding in the central atom is less than 8 electrons. Clear? But according to the octet rule, and terminal atom and central atom should have the 8 electrons, should attain the octet. Then only they are stable. But here some cases, what are those? I will write some examples here. So I will take here beryllium chloride, not beryllium, boron trichloride I will take. Clear? Beryllium hydride. If I write here beryllium hydride, this is the structure, Lewis dot structure of the beryllium hydride. You already know how to write, and I am just writing here. Clear? So in this case, you see hydrogen complete doublet. This hydrogen complete doublet. But you know this beryllium is having how many electrons here? 4 electrons. Means this number of electrons surrounding the central atom is less than 8, less than octet. If less than octet means this molecule should be unstable, but this molecule is a stable. In the same way, if I take boron trichloride, and this is chlorine, and here chlorine, and here chlorine. You know chlorine will have 3 electrons, 3 lone pair of electrons. Clear? If you see in this case, and all chlorine atoms, you know, attain the octet. But if you take the boron here, boron if you take, how many electrons are there? You see around the central atom here, 6 electrons. Clear? The central atom is having here 6 electrons, less than octet. And this molecule also stable. But according to the octet rule, these 2 molecules should be unstable, because according to the octet rule, and each and every atom in the molecule should attain the octet, then only it is stable. But here they are not having the 8 electrons in their valence shell. But these molecules are still stable. Why they are stable? Not explained by the octet rule. Clear? That is the first one. Clear? Second one, odd electron molecule. Some molecules are having odd number of electrons. And odd number of electrons means, you know, and paired electrons will be there, and there is a one unpaired electron is there. And those type of molecules will be considered as a odd electron molecules. Clear? So those molecules also means in those molecules, you know, in those molecules, the octet rule is not satisfied for all the atoms. Clear? Even though they are stable. I will write one example here. If I take example nitric oxide. What is the example here? If I take nitric oxide, I will write here NO. Total how many electrons are there here? Nitrogen 5, oxygen 6. Total how many? 11 electrons. 11 electrons means I will put here 2 electrons, clear? And remaining I will write in this way. Total here what it is now? Oxygen is attaining the what it is? Octet. And now, and how many electrons left here? 8 electrons I used, 3 electrons left here. I will write 2 electrons and here 1 electron. I will write 1 electron. This is, you see, in this case, nitrogen, oxygen attaining the octet, but nitrogen not. If I keep 2 electrons here also, if I write, you see, I will write and 2 electrons, and here I will write, see now. If I write this here also, same. What will happen, you see? And this is octet, but here this is what it is. How many electrons are there? 7, and here 8. Clear? So means in this case, this octet rule is not satisfied for all the atoms. Oxygen is satisfied octet, but nitrogen is not satisfying octet. But still, this molecule is a stable. This molecule is what it is here? Stable. So why these stable odd electron molecules? Why they are stable? Not explained by the octet rule. And this is another one example. Clear? In the same way, if you take another example is there, NO2. Clear? What it is here? NO2. This is the Lewis dot structure. If you see, if you write the Lewis dot structure, you will get like this. This is, you know, formal charges. I already mentioned how to calculate the formal charges. This is NO2 molecule. Here you see, odd number of electrons is there. Still they are stable. Why they are stable not explained by the octet rule. This is one of the exception of octet. Clear? Next example is extent of octet. Sometimes they will ask what is extent of octet in the PU examination. Clear? So what is extent of octet means? You know that the number of electrons surrounding the central atom is more than 8, more than octet. Clear? Those molecules, those will be called as this is termed as a expanded octet. And here you see number of electrons surrounding the central atom is less than 8, but here more than. Expanded means more than 8. Clear? And those molecules are there, and those molecules are also stable even though the central atom exceeds the octet. And why those are stable not explained by the octet. So what are those molecules means? I will write here PF5. What is one here? This is mainly for the third group elements. Clear? So third not group, third periodic elements. Clear? So what is the first case? Pass PF5. If I write here example PF5. So what is the Lewis dot structure? If you write the Lewis dot structure, and here fluorine, and fluorine. This is the Lewis dot structure. Clear? So you know that here halogens will have 3 lone pair of electrons. If you just write how we have discussed, and you will get the Lewis dot structure like this. Clear? So here these are 2 electrons. I have written these 2 electrons as a single bond. Clear? If you see the central atom is having how many number of electrons here? These bond means how many electrons? Bond means these are 2 electrons. These 2 electrons are belongs to the both the atoms, fluorine and phosphorus. So that's why this phosphorus is having 5 here 2 electrons, 2, 5 bonds means how many electrons? 10 electrons. So here this is central atom is phosphorus is having how many electrons? Here 10 electrons. In the same way, SF6 if I take, sulfur, in this case fluorine and same fluorine, and here fluorine, and this is SF6. Now how many electrons are there around the central atom here? How many bonds are there here? 6 bonds. 6 bonds means how many electrons? 12 electrons. So around the central atom how many electrons are there? 12 electrons. So in the same way, if I take H2SO4, what is the structure of H2SO4 means? This is the structure of H2SO4. Clear? So you have to write here lone pair of electrons. Clear? So you know how to write this is. I am directly writing. You know how to write the Lewis dot structures. In this one you see sulfur is having how many bonds here? 1, 2, 3, 4, 5, 6. 6 means how many electrons here? 12 electrons. So they exceeds the central atom exceeds the octet. So that's why we will call this extended octets. Even though and central atom is having more than 8 electrons, they are very stable. Clear? They are stable. Why they are stable? Not explained by the what it is one here octet rule. And another two limitations are there. I will write what goes to here. So these are some other limitations of octet rule, and this rule does not account for the shape of the molecules. What does it mean? Shape of the molecule. So, and we are writing here skeletal structure. Skeletal structure we are writing in our own. We are keeping the central atom and we are arranging the terminal atom in our own way. But actually, and it is not the correct shape of the molecules how we are writing. In some molecules it may match, but some molecules it won't match. Previous, I mentioned one example here. HNO2. Have you remembered here? HNO2. HNO2 means what is the central atom here? Which one is the least electronegative atom? Hydrogen. But you know that hydrogen cannot act as a central atom. So that's why. Oxygen and nitrogen. Which one is less electronegative? Nitrogen. So nitrogen is the central atom. Clear? Now, if you take oxygens, and we should arrange in this way: oxygen, and nitrogens. Oxygen, and what is the hydrogen? Clear? But we have not written hydrogen here. We have written hydrogen here with the oxygen. If you write hydrogen here, you will get different shape, a different molecule. If you write hydrogen here, you will get different molecules. So why we have to write in this way? Hydrogens we have to write with the highly electronegative, not directly to attach here nitrogen. Clear? So that's why, and we don't know that is why we should not write this. and this is unable to explain. So that's why, and this is does not account for the shape of the molecule. If you put here hydrogen, you will get one shape. This molecule will have different shape, and if you put the hydrogen here, and this molecule will have the another shape. So that's why it does not explain the shape of the molecules. And also sometimes what we will write here. So if you take some examples, you know, suppose NH3 is there. So how we will write here? Sometimes we will write hydrogen, hydrogen, hydrogen here, like this. But it is not the exact shape of this molecule. Actually, you have to write in this way. This is the shape of the molecule. But we are arranging, just we are keeping the central atom, and around that, in our own way, that is skeletal structure. In our own way, we are arranging the terminal atom around the central atom. But it will not give exact shape of the molecule. Clear? So that's why, and this theory or this rule is failed to explain the shape of the what it is here molecules. And next one, it does not explain the relative stability of the molecule. Clear? I mentioned here some molecules incomplete octet of central atom. Clear? And those molecules, they are not in the central atom, is not having the octet 8 electrons, even though they are stable. But here you see central atom is having the more than 8 electrons, more than octet, but they are stable. Why they are stable? Why they are, you know, even though it is molecule central atom is having less than 8 electrons, or central atom is having more than 8 electrons, still they are stable. Why they are stable? Not explained by what it is not here, you know, octet. So that's why it does not explain the relative stability of the molecule, and also it does not explain the energy of the molecule. Clear? You know, stability actually depends upon the energy of the molecule. Clear? He mentioned that if molecules, all the atoms in the molecule attain the octet, they are stable. But what about the energy of that molecule? He couldn't explain. Clear? So these are the limitations of what is octet rule, very important for your PU examination. So exceptions, mainly 3 cases are there. One is incomplete octet of the central atom, odd number of electrons, and extended octet. Along that, and these 3 limitations are there, and these are about what it is here, limitations of what it is octet. So next concept is here covalent bond. We already mentioned this is chemical bonding. So I mentioned in the first video, and we will discuss in this chapter about the covalent bond, ionic bond, and dative bond. So the first one is here covalent bond. Clear? And this covalent bond was introduced by Lewis, and after that developed by Langmuir. Clear? So what is the covalent bond? Previous ones roughly I have mentioned previous. So I have explained already. And covalent bond is formed by what it is here? Sharing of electrons between the 2 atoms. Clear? Transfer of electrons means which bond? Ionic bond. Sharing of electrons means which bond? Covalent bond. Clear? So what here? The bond is formed between the 2 atoms by mutual sharing of valence electrons. Mutual sharing of what is valence electrons, and that bond we will call as a what is here covalent bond. Yeah. So shall we write this is first one what it is here? This was covalent bond was proposed by. It was proposed by what it is here? Lewis, and also developed by what it is here? Langmuir. Yeah, so this is. So what is the definition of covalent bond here? The bond is formed. The bond is formed between 2 atoms. Between what it is here? 2 atoms. By mutual sharing of valence electrons. valence electrons is called, valence electron is called as, or is known as what is known here, covalent bond, is known as covalent bond. Clear here? This is the definition. Sometimes they will ask what is the definition of covalent bond. So what it is here? The bond is formed between the two atoms by mutual sharing of valency electron, is known as a, what it is here, covalent bond. Clear? I already mentioned simple example. If I say here hydrogen, and you know hydrogen is having one electron, so I will write here. So hydrogen is having one valence electron, another hydrogen is having one valence electron. Clear? So what will happen here? One electron means it is unpaired electron means those molecules are not stable. To get the stability, they should either the doublet or the octet. Clear? So that's why, and they will share these two electrons each other. So what it will give one electron, and this hydrogen will give one electron, and they share those two electrons. Clear? So now this hydrogen is in the doublet, and this hydrogen also in the doublet. So that's why, and these two electrons are mutual sharing shared by two hydrogen atom, and this we can write as a two electrons means we will represent it by the one bond, single bond, and this bond we will call here as a covalent bond. This bond we consider as which one? Yeah, covalent. Okay, that is mutual sharing of electrons. Clear? And very important here, only unpaired electrons in which atom has involved in the formation of covalent bonds. Clear? What it is here? Only unpaired electrons. That is also you can write here. Only unpaired electrons. Unpaired means what it is? Not paired, single electrons. Clear? So only unpaired electrons involves in formation of covalent bond. In formation of which bond? Covalent bond. Only unpaired electrons. Clear? Paired electrons will not involved in the formation of covalent bond. Clear? So that is only unpaired electrons involved in the what it is here? Formation of covalent bond. Clear? So another point here. How many bonds that atom, covalent bonds that atom can form means that is equal to number of unpaired electrons that atom has. Suppose atom is having 3 unpaired electrons. It can form how many covalent bonds here? 3. Suppose the atom is having 5 unpaired electrons. It can form 5 covalent bonds. Means what I can write here as a very important point. Number of covalent bonds formed by an atom is equal to number of unpaired electrons that atom has. Clear? So simple example like this. So I will write here phosphorus. Clear? Phosphorus, you know, nitrogen phosphorus. Clear? So what is the electronic configuration? We have already studied in the atomic structure how to write the electronic configuration. If you write here phosphorus belongs to third, means phosphorus belongs to fifth group. So what is the electronic configuration? Outermost electronic configuration 3s2 and 3p3. This is clear. Helium 3s2 3p3. Nitrogen and what is here? Phosphorus. Now phosphorus here, you know, in this one s orbital how many electrons are there? 2 electrons. In the p orbital how many electrons are there? There are 3 electrons. 1, 2, 3. This is the ground state electronic configuration. This is which state here? Ground state electronic configuration. What is here? 3s2 and this is what we will call 3p3. So in the ground state electronic configuration, phosphorus can form how many covalent bonds? See here, how many unpaired electrons, single electrons are there? 3. these electrons will involved in the formation of covalent bond? No. Why? Because these electrons are paired electrons. So that's why. And here phosphorus can form 3 covalent bonds. 3 covalent bonds in its ground state. It's what is here? Ground state. And if I mention instead of the ground state excited state means what it is? This is excited state. Clear? Now what happened? Same, I will write here 3s2 and here what is 3p3. Next what will come? 3d. Which orbital will come after 3p? 3s2, 3p and 3d. D orbital how many? 5. P orbital how many? 3. S orbital how many? 2. So this is 3p3. When it is in the ground state, this is the electronic configuration. Excited state means what man? You have to supply some energy to the atom. So that's why that energy is taken by the electrons and they will jump from the ground state to higher energy. They jump from the ground state to higher energy state. Means, and here one of these electron will jump into the 3d electrons. Clear? How many unpaired electrons are there here? 5. So that's why phosphorus can form how many bonds here? 5 bonds. That is, phosphorus can form. Clear? 5 covalent bonds. Cg means covalent bonds. Clear? 5 covalent bond in its what it is here? Excited state. Which state here? Excited state. In the ground state, because that what I want to tell here, the number of covalent bonds formed by an atom is equal to the number of unpaired electrons. So only unpaired electrons will involved in the bond formation. So in the ground state, phosphorus is having only 3 electrons, so it can form how many covalent bonds? 3 covalent bonds. But excited state of the phosphorus, one of the electron from the s orbital will jump into the 3d orbital. So here how many unpaired electrons we have? 5. So that's why it can form the how many bonds? 5 bonds. So just now we have discussed about the covalent bond. Clear? Now, and we have single covalent bond, dicovalent bond and a tricovalent bond. Clear? How they will form, and we will discuss here one by one. Clear? Single covalent bond. Single covalent bond means what is a single bond between the 2 atoms. Clear? How single bond will form between the 2 atoms? By mutual sharing of pair of electrons. And that it gives the single covalent bond. Clear? Single covalent bond is formed by the mutual sharing of one pair of electrons between the 2 atoms. One pair will be there and that pair will be shared by the 2 atoms only. Clear? So that is, you will get the single covalent bond. Just I have written already hydrogen. I will take here chlorine. Chlorine means you know how many valence electrons will have chlorine? 7 valence electrons because it is belongs to 7 period. Clear? And I will combine 2 chlorine atoms. Clear? So 2 chlorine atoms. Clear? This chlorine is having 7 electrons, 1 electron less for the octet, and this chlorine is also having the 1 electron less for the octet. Clear? So to get the stability, and they need this chlorine need 1 electron, this chlorine also need 1 electron. So what they will do? They will come from one understanding and mutual sharing. Clear? And that's why what happened here, you will get the chlorine, and here this is the chlorine, and this is gives electron, and this is also gives electron, mutual sharing, and that electron I will write here. Clear? So now chlorine, and this is the another chlorine. Now you see both chlorine atoms attain the octet, and this is chlorine attain the octet, and this chlorine also attain the octet, and this pair of electron is mutually shared by what it is 2 atoms. So that due to this you will get what it is 2 electrons between the 2 elements means the 2 electrons are represented by which bond? Single bond, and that is will be called as a single covalent bond. This is what it is here, single covalent bond. Single covalent bond. Clear? So dicovalent bond means how many electrons should be shared here? 1 pair of electrons means single bond. 2 pair of electrons means double bond. 3 pair of electrons means triple bond. That is what I have written. Dicovalent bond. Double bond is that can be called as a double bond. Double bond is formed by the mutual sharing of 2 pair of electrons between the 2 atoms. I will take one example here. Oxygen. What is the example here? I will write oxygen. Oxygen means having how many electrons here? 6 electrons. Valence electrons, how many? Oxygen is having 6 valence electrons, and I will write another one oxygen. So plus this is clear now? Another one oxygen. Clear? So now this oxygen is having 6 electrons. This oxygen is also having the 6 valence electrons. 2 electrons are less for the what it is octet, so that's why. And those 2 electrons will be mutually shared by these 2 oxygen. So what you will get? You see, I will write here oxygen, and here one pair and one pair. I will write this is pair here, and this pair also I will write here oxygen. So this is oxygen and oxygen. Clear? Now you see, this oxygen is having what it is 8 electrons, and this oxygen is also having how many electrons? 8 electrons. But how many pairs are shared by these 2 atoms? 2 pairs. So that's why what we can write here oxygen, and that 2 pair I will write as a what it is here double bond. This can be written as like this. So it is a which one? Dicovalent bond. That will be considered as a. That means this dicovalent bond is formed mutual sharing of 2 pair of electrons. These 2 pair of electrons shared by both the atoms, and you will get that double bond. And tricovalent bond means how many electrons will be shared? 3 electrons. I will write simple example here. Nitrogen. Nitrogen, what it is Nitrogen is having how many valence electrons? 5 valence electrons here. So that's why I will write here nitrogen is having 5 valence electrons. Clear? So I will write here 5 valence electrons. This is another nitrogen. Another nitrogen also I will write here 5 valence electrons. Clear? So now mutual sharing. You see, this is it is having 5 valence electrons. To get the octet, how many electrons required? 3 electrons, and these 3 electrons will be shared. This is also required 3 electrons, and this nitrogen also required 3 electrons to get the octet. And these 3 electrons, each nitrogen, will share and get the octets. That is how you will write here nitrogen, and here 3 electrons, and here 3 electrons, nitrogen. Now you see both are in the octet or not? This is octet, and this is also in the octet. So how many pair of electrons shared here? 3 pair, and this is 1 pair. This is 1 pair, and this is 1 pair. How I can write here? This is N triple bond N. This is the triple bond. That is tricovalent bond, and this. So these double bonds and triple bonds can also be called as a multiple bonds. So this is about single bond and a dicovalent bond and tricovalent bond. Now, and we will discuss here, next topic is types of covalent bonds. Types of covalent bonds. Types of covalent bond. So we have 3 types of covalent bonds here. So what are those? I will write, and the next I will explain. So one by one here. Clear? What is 3 types of covalent bonds are there? One is non-polar covalent bond. One is what it is non-polar covalent bond. Clear? Next one is polar covalent bond. Polar covalent bond. Yeah? And the third one is here partial ionic bond in covalent bond. This is the 3 types. Clear? So how many types of covalent bonds we have? 3 types. Non-polar covalent bond, polar covalent bond, some partial ionic character in covalent, or partial ionic character of covalent bond. These are the 3 types. Clear? I will explain one by one what are the non-polar covalent bond, polar covalent bond, and partial ionic bond of covalent bond. So here the first one is non-polar covalent bond. Clear? So what is non-polar covalent bond and how it will form? This can also be called as pure covalent bond. Clear? And this covalent bond, non-polar covalent bond or pure covalent bond, is formed between the 2 similar atoms. Clear? So you see, this bond is formed between the 2 similar atoms by sharing of, you can write here, the covalent bond is formed between the 2 similar by sharing of pair of electrons between the 2 similar atoms. Mutual sharing of pair of electrons between 2 similar atoms. Clear? So what does it mean? You see, and I will write here hydrogen or chlorine I have written here. chlorine, and this is one electron, and this chlorine is also having one electron. Means how many valence electrons? 7 and 7. Clear? I already mentioned. And if these two electrons are shared by, means it needs one electron, it gives, and it needs one electron, it gives, and both will share. Clear? Then what you will get here? You will get chlorine, and here this is one electron, and you know 2 pair of electrons, and this is. So both are getting what it is now? Octet, that is. Clear? This pure covalent bond is formed by the mutual sharing of electrons between two similar atoms. Between what it is now here? Two similar atoms. And this covalent bond, what we will write here? C and here Cl. And this covalent bond, you know, we will call it as a non-polar covalent bond, or can also be called as what is here? Pure covalent bond. Clear? Between two similar atoms, the sharing of, mutual sharing of electron pair between two similar atoms, non-polar covalent bond, and mutual sharing of pair of electrons between two different atoms, that is a polar covalent bond, that we will discuss next. Clear? So in this one you see that, and next point, shared pair of electrons are almost in the center, you know that, and this is chlorine and this is shared pair of electron, because both are having same electronegativity, and these electrons are equally attracted by the two chlorine atoms. So that's why this chlorine atom lies almost in the center of these two atoms. Clear? And this is not displaced, this pair of electron, it is not displaced towards any one of the atom. If suppose I will write one example here, A and B, and we are forming one bond. Clear? This is A and B. This is A and B. This is what we can write here. Two electrons are there. Bond. Suppose B is more electronegative than A, and this electron will shift towards which one? B. Then what you will get here? And you will get this electron pair is close to which one? More electronegative atom. Okay? But here both are, you know, same electronegative atoms. The pair of electron, it lies almost in the center and not attracted towards any one of the atoms. If it is not attracted, then there will be no chance of formation of holes on the atom, on the atoms. Clear? Suppose I mentioned here, suppose here only I mentioned, you see, B is more electronegative than the A. Then it gains the, it will take the electrons from the which one? A is losing electron, means A acquires what it is now? Partial positive charge. B is gaining, acquires partial negative charge. When if the two atoms are different and one atom is more electronegative than the other, then holes will be created on the atoms. But here there is no chance. Why? Both are same electronegative atoms, so holes will not be generated on the clear atoms. Why? Because they are not attracting the shared pair of electrons towards any one of the atoms, and that we will get the what is it? Non-polar covalent. Once you see what I explained, this is example. You can write there example. So that's why this is the chlorine and this is the bond, and this pair share of electrons. These electrons will be where now? It is exactly like center. Clear? So that's why it is not attracted towards any one of the atom, so poles will not be generated and formed. So that's why poles is not formed. So we will call as a non-polar covalent bond. Clear? So that is, the bond is formed by mutual sharing of pair of electrons between two similar atoms. That is the pure covalent bond. Shared pair of electron lies in between the center. Electrons are equally attracted towards two atoms and are not displayed towards any one of the atoms. When it will displace, if the both atoms are different, one is more electronegative than the other, then the atoms will be displaced towards any one of the atoms. But here same electronegativity, so that's why not displayed. Hence no poles are formed and the bond is completely non-polar covalent bond. So example chlorine, and this is the example. Clear? Now I will discuss here about the polar covalent bond. I will discuss about the polar covalent bond. First I will explain, and after that I will write the points. What is the polar covalent bond. Clear? So just listen, and after that I will write all the points like how I have written for the non-polar covalent. So polar covalent bond, if you take this non-polar covalent bond is formed between the two similar atoms, but here two different atoms. This is clear. You know that chlorine is having one electron, and this hydrogen is having one electron, valence electron. Chlorine is having 7 valence electrons. And the hydrogen need one electron to get the doublet, and the chlorine need one electron to get the octet. Then what they will do? They will share these two electrons. Clear? Then what happens you see? And here chlorine, clear? So chlorine, and this is both you see. This is it gets doublet, and it gets what it is? Octet. Both are what it is? Stable. Both are stable, and thus one pair of electron is shared between the two atoms. One pair of electron means what we will write now? We will write this bond as a HCl. But if you see in this case, this shared pair of electron is close to chlorine than the what it is hydrogen. Why? Because chlorine is more electronegative than the what it is hydrogen. So that's why. And chlorine, it attracts the pair of electrons towards it. Clear one? So that's why. And in this one, shared pair of electron is attracted towards the more electronegative atom. And due to this, what will happen? You see, this is simple. You see, this is hydrogen. This is what it is chlorine. Clear? And you know chlorine is more electronegative, so that's why these electrons are taken by what is here. One bond is there. Just assume one bond. One bond means how many electrons? 2 electrons here. Clear? So that's why these electrons are taken by which one? More electronegative chlorine. Hydrogen is losing electron. So that's why it acquires what it is? Partial positive charge. Chlorine is gaining electron partial negative charge. And here electrons are there. So this pair of electrons are towards attracted, displaced towards more electronegative atom. Due to that, holes are generated on the atoms. So that's why, and this bond, due to this attraction, positive and negative attraction, and that bond will form. That bond we will call as a what is here? Polar covalent bond. Clear, my dears? So I will write the points here. You note down next. And what it is here? Simple. Non-polar covalent bond is formed between the two similar atoms, and polar covalent bond is formed between the two different atoms. So here I have written next one is polar covalent bond. Clear? Non-polar covalent bond we have discussed, and I already explained what is the polar covalent bond. Clear? So I mentioned here. The bond is formed by the mutual sharing of 2 electrons between 2 different atoms. Non-polar covalent bond is between 2 same atoms or similar atoms. Clear? So I already mentioned shared pair of electrons is displaced towards more electronegative atom. I already mentioned here one bond means 2 electrons, and because chlorine is more electronegative than hydrogen, this bond pair electrons are attracted towards the chlorine. Chlorine attracts the bond pair electrons towards it. So that's why this bond pair electron or shared pair of electron is displaced towards more electronegative atom, that is chlorine. Clear? And during this process, because it is chlorine is taking electrons away from the what it is hydrogen, means hydrogen is losing electron. Losing electron means acquires which charge? Positive charge. Gaining electrons means acquires what it is negative charge. Means when the bond electrons are shifted towards the bond pair of electrons shifted towards the chlorine, hydrogen acquires positive charge, and other atom means here what a chlorine acquires the negative charge, other atom acquires what is positive charge. So the positive and negative poles are produced, and the bond is completely what it is polar, and that bond we will call as a polar covalent bond. This is the one of the example. Clear? That is polar covalent bond and non-polar covalent bond. Clear? Polar covalent bond between 2 different atoms, non-polar covalent bond between 2 similar atoms. Clear? So electronegativity difference between the 2 atoms and the non-polar covalent bond is 0 because same atoms. Electronegativity difference is not there, but here electronegativity difference is there. So that's why pair of electrons they shift towards the more electronegative atom. When electron is shifted to one atom acquires positive charge, and which gains the electron, that atom acquires negative charge, and poles created, and that's why that bond, that attraction, this attraction, negative and polar attraction, attractive force will be called as what it is now bond, and that bond will be called as a polar covalent bond. And third one is what it is here. Third one is partial ionic character of covalent bond. Put the third one is what it is here. Partial ionic character. Partial ionic character of covalent bond. This is the third one. Okay, so means covalent bond also sometimes it will have the ionic character. So it depends. The ionic character of the covalent bond depends upon the electronegativity difference between the two atoms. Clear? More the electronegative difference and more will be the ionic character in that covalent bond. Clear? So that is. So here ionic character of covalent bond. Ionic character of covalent bond depends upon difference in the electronegativity, difference in electronegativity of two atoms. Electronegativity of what it is here? Two atoms. Clear? Greater the electronegativity difference, greater the electronegativity difference. Clear? So what it will be? Greater the ionic character. Greater the ionic character in covalent. Clear? And here, how much percentage of ionic character is present? Ionic character. Percentage of the ionic character in the covalent bond can be calculated. We have some formula. So ionic character of the covalent bond can be calculated. One formula, two formulas are there. One is 18 into Xa minus Xb whole power 1.4. This is one formula. Another formula is there. What is the another formula? 16 into Xa minus Xb plus 3.5 into Xa minus Xb whole square. This is the two formulas and can be used to calculate the ionic character in the covalent bond. What is Xa and Xb means what is one? Electronegativity value of A and electronegativity value of atom B. Clear? So this is the, we see also electronegativity of atom A and electronegativity value of atom B, and do this one and you will get the ionic character in the covalent bond. Very important formulas. This is about the types of what it is here, covalent bonds. Now next one, factors favoring the formation of covalent bond. Very important concept this is for the competitive. So many times they are asking questions based on this concept. Clear? So what is factors favoring? First I will write what the factors favoring the formation of covalent bond, and after that I will explain. Clear? So the first one right here, the first one is small size of cation. Small size of what it is here? Cation. Small size of cation means what is it? The atom which acquires positive charge, means atom having positive charge, that will be called as a cation. Atom having negative charge, that will be called as a anion. Clear? So small size of cation favors the formation of covalent bond. And next one is large size of anion, and also favors the covalent bond. And third one, large charge on both cation and anion. Both cation and what it is here? Anion. And last one, this is last I will explain. This is pseudo electronic configuration. Pseudo electronic configuration. Okay.